Hey everyone, welcome back. Today, we are breaking down the key topics that often come in the interview. The difference between KNN and Kmeans. Don't worry, we are making it so simple that even the school grade can understand this. Plus, I will show you how to explain in technical interview with the code example to make sure you are ACA this question. Let's jump right in. Now let's dive into KNN or in K nearest neighbor. This is a simple yet powerful algorithm, and I will explain in a way that easy to understand and using the analogy that can you use in the interview. Imagine you move to a new neighborhood and you want to know which sports the kids in your neighborhood likes. You see that there is a kids playing the football, cricket and basketball. To guess what sports a new kid might be like, you could be look at what your neighbor kids are playing. If the most of them are playing the football, then it's likely that the new kids might be like the football too. This is how KNN works. It's a supervised learning algorithm that makes the prediction based on the neighbors or nearby data points. Here, how you can explain in the technical interview. First, the algorithm finds the k closest data points or neighbors, and to a new data points what you want to predict. It then looks at the labels of these neighbors, like checking what the sports the nearby kids are playing. The algorithm predicts the label of the new data points based on the majority label of these neighbors. So, if the most of the neighbors plays the football, it predicts that the new kid like the footballs too. Let's get a bit more technical. In KNN, K is the parameter that you choose, which decides how many neighbors to be considered. If you choose K is equal to 3, the algorithm looks at the 3 closest neighbors. The distance between the points is usually calculated using the methods like Euclidean distance, which means straight line between the 2 points. One important thing to mention in the interview is that KNN is a lazy learner. That means it doesn't learn anything during the training period. It just memorizes the training data. The actual computation happens when you make the prediction. This makes KNN simple to implement, but it can be slower with large dataset. To sum it up, KNN is all about finding the closest neighbors and making prediction based on what they are doing. It's like moving into a new neighborhood and predicting that the new kid with like the same sports as the majority of the neighbor kids. Alright, now that we have understood the basic concepts of K nearest neighbor, let's jump into simple code example to see how it works in action. We'll use the Python and the scikit-learn library, which makes the implementation of the KNN very straightforward. As you know, imagine we have a group of kids in the neighborhood and we know their favorite sports. We want to predict the favorite sports of a new kid who just moved into based on the preference of the new neighbor kids. Here is the data. This array represents the height and weight of each kids in the neighborhood. So for example, the first kid is 150 cm tall and 50 kg weight. Now we have the corresponding sports they like. These labels are what we call target labels in the machine learning. Here 0 stands for football and 1 stands for cricket and 2 for basketball. So the first kids like football, third kids like cricket and so on. Next, we have a new kid who just moved into the neighborhood, and we want to predict the what sports they might like based on their height and weight. These new kids having the 165 cm height and 60 kg. Let's add it. Now let's create our KNN model. We will set k is equal to 3, meaning we want to look at the 3 closest neighbor to make our prediction. The k neighbors classification is the function from the scikit-learn that helps to create the KNN model. We have specified that we want to consider 3 neighborhoods by setting k neighbors is equal to 3. Next, we will train our model using the data we have on the kids' height, weight and their favorite sports. This step is where the model memorizes the data. Remember, KNN is a lazy learner, which means it doesn't do much during the training. It just stores the data and wait until it needs to make a prediction. Now coming to fun part, making a prediction for the new kid. The predict function looks at the 3 nearest neighbor to new kids in terms of height and weight, and then predicts the sports based on the majority preference among these neighbors. Finally, let's translate the numeric prediction back into the actual sports name so it's easier to understand. So we have created the dictionary called sports name. To map the numbers back into a sports name, this makes our output user friendly, and when we run this code, it tells us what sports the new kids is mostly like to play based on the neighborhoods. Let's execute. Cricket. So the new kids likes to play cricket as per our model and the data. The code predicts that the new kids like to play the sports most commonly among the neighbors kids are playing in the neighborhood. Using their height and weight, make that the decision. This is simple example shows how KNN works in practice, and it's great way to explain the concepts during the technical interview. Now, let's move into Kmeans. Imagine you have a box of different colors marble and you want to sort them in a group by a color. Kmeans help you to do that by grouping a similar item together. It's an unsupervised learning algorithm, which means it doesn't need any label data. Kmeans tries to divide your data into K cluster, where each data has items that are similar to each other. For example, it could group customers who shops at your stores into a different category based on buying habits. Alright, let's talk about how you can explain Kmeans in a way that easy to understand and will be stick to your mind, especially for the interview. Imagine you are at the school picnic. All the students are scattered around the big playground. The teacher wants to form a group of students who are standing closer to each other. What teacher does is the first pick a few students randomly to be a group leader. Let's say 2 students. Then all other students move closer to nearest group leader. This forms 2 groups. But there is a trick. The teacher looks again and decides the adjusting the group leaders to better position so that group are the more balanced. This process is repeated a few times until the group doesn't change anymore. Here is how you can break down in the interview. First, algorithm randomly select the K points, which are the initial cluster centroid or a centroid. Then each data point is assigned to a nearest centroid, forming a K cluster. Next, algorithm recalculate the centroid and based on the point in each cluster, essentially find the middle point of each cluster. This process is repeated until the centroid is no longer changed, meaning that cluster has been stabilized. This step-by-step adjustment makes Kmeans a powerful tool for grouping data even when you don't have the label or categorized in the advance. You can compare this to teacher repeatedly adjust the group leader until everyone are in the best group possible. In an interview, you can add that one of the challenge with Kmeans is choosing the right value of K, which is the number of clusters. You can mention using the elbow method to find the best K. It's like deciding the right number of groups so that students in each group are not a few or too many. Alright, let's dive into the fun and practical example of Kmeans clustering. Imagine a group of students playing on the playground, and we need to organize them into 2 groups based on their position. We'll use the Kmeans clustering to help the teachers to figure out where the groups naturally form. In our scenario, we have X and Y coordinates of each student on the playground. These coordinates represent where the students are standing. Let's take a look at the data. First, we will import the necessary libraries. Kmeans from the scikit-learn clustering for the Kmeans algorithm, and the NumPy for handling the arrays, and matplot.pyplot for the plotting the result. Now we have got everything needed to start the clustering. Next, let's define the position of the students. Each point in the array represents where the student is standing on the playground. Here, each pair of numbers represents X and Y coordinate of the student. For example, the first student position at 2, 3. Fourth student represent the position at 8, 8. Now teacher wants to format 2 groups. So we set the number of cluster to 2, that is K is equal to 2. This means that we want to divide the students into two clusters or a group based on the positions. Next, we create our K-means model with the K clustering and fit it into student position. The K-mean clustering starts by randomly placing a two centroid on the playground. These centroids acts like a group leader, that is, the students will gather around. The algorithm then assign each student to nearest centroid, recalculate the centroid based on the new groupings, and repeat this process until the centroid is stabilized. Once the model is trained, we can get the final position of these group leaders or a centroid. These centroids are the center point of the two groups. They represent the average position of all the students in the each group. Now we will predict which group each student belongs to using the training the model. The predict function tells us which cluster or a group each student is assigned to based on their position. Let's visualize the results by plotting the students on the playground along with their assigned group and the centroid. In this plot, each student is shown as a dot, and the color represents the group of or belongs to. The large red X marks represent the centroids or a group leaders. You can clearly see that how the students has been divided into two groups based on their position. Finally, let's take a look at the cluster assignments and the position of the centroid. The output tells us which clusters each student belongs to and where the centroids are located. This information can help the teacher to organize the students efficiently, ensure they are grouped with others' neighbors. We have successfully grouped the students into the two clusters based on their position on the playground. This example not only demonstrates the power of K-means clustering, but also shows how it can be applied in real-world scenarios, even in something as simple as organizing kids on the playground. If you are in an interview, explaining this code with a playground analogy can really help make the concepts of K-means clustering clear and memorable for your interviewer. By explaining it this way, the interviewer can see that you are understood both concept and practical application of the K-mean. Plus, using the real-life example like school picnic make it to easier remember and talk about during the interview. Imagine you are working at a video streaming company. You can use the K-mean to group a user based on their watch history and then use the KNN with each group to recommend the movies. This way, you are combining the strength of both algorithms to create a smart recommending system. This approach shows that you not only understand each algorithm but also how to use them together in the real world scenario. That's the kind of thing stands out in the interview. If you found this video helpful, make sure to give a thumbs up and subscribe and share this video with your friends. And don't forget to hit the bell icon so that you never miss any updates. Thanks for watching and good luck with your interview. Until next time, bye bye.